Hi, welcome back, and today we're going to talk about complex numbers. We're going to start talking about how to put or give a complex number in the form of as a multiple of I. So in other ways, we're going to also introduce imaginary numbers. Okay, so the topic is expressing square roots of a negative number as a multiple of I, and this is what we call an imaginary number. And this is going to give us an introduction to what we call complex numbers. So before we begin, we know how to take square roots of positive real numbers. But what happens when we have to deal with the square root of negative numbers? We normally say that, hey, well, we can't deal with those, right? We put a square root of -3 in our calculator and we get an error. Okay, or it'll give us a message saying not real. Okay, so how do we deal with that? Well, we're going to there's lots and lots of fields in physics, mathematics that deal with negative numbers. And so we have to, especially roots of real numbers or even roots or square roots of real numbers. So we have to have a way of dealing with that. So in math, we defined I. Okay, so we're going to deal with the number I. And so I is defined as quite simply the square root of -1. And this gives us a very nice and easy way to, gives us a way of denoting things that are hard to deal with, or lets us be able to handle them in a mathematical way. Okay, so now, how does this work? How does this help us? Well, now we have a way that we can use properties of powers and the definition of I to help us solve different problems. For example, what if I wanted to know, well, what if I do I squared? Well, I squared is what? The square root of -1 squared. And so, of course, the square root is undone by the square, so what do we get? We get -1. Well, what if I want to do I cubed? Well, we could look at it as, and this is just one way we could look at it, we could look at this as I times I squared. And so since we already know what I is, or I squared is -1, so we know this is -1, and then I is just the square root of -1, or just I. So what do we get? This is going to be -1 times I, which just gives us -I. So I cubed gives us -I, or negative square root of 1. And then, of course, if we do I to the 4th, well, we could split this up and say, okay, well, this is I times I cubed, right? And we know I cubed is -I, right? Okay? And so this is I times -I, which gives us -I squared. Well, what's I squared? I squared is -1. So this gives us a -1, which gives us 1. Now, this is not the only way you could have done it. I could have split it up like this. I could have said I squared times I squared. Well, we know I squared is -1, so that would give us -1 times -1, which would have given us the same thing. Okay? So there's different ways of doing this. But that's one thing that we can do with I. Okay? Now, what's the other thing that we could do? Well, we can now take the square root of a negative number and we can represent it as a multiple of I. Okay, which is what we're talking about today. So let's take the square root of -49. Okay. Well, normally if this was just positive, it would just be 7. But it's negative, so what happens here? Does it become -7? That would be wrong. Okay. So what do we do? Well, we use the property of roots here. So we start with the inside and we write this as the square root of, well, we got -49. We can write this as -1 times 49, right? There's nothing wrong with that. And then what we could do is we could split this up into two radicals by using the properties of radicals. So this would be -1, or the square root of -1 times the square root of 49. Well, lo and behold, what happens this? Well, this is just I, right? And the second one is just 7. So how do we write this? Well, we treat this like it's a variable, even though it's not a variable, but just like the number E, right? So this would be the number I. So we always put the constant in front. So this would be represented as 7I. And this would be what we call an imaginary number, okay? And so the square root of -49 is equal to 7I, okay? Now, a complex number is given by two pieces. So when we talk about complex numbers is a number that is a combination of a real part and an imaginary part. So a real number and an imaginary number. Okay? So a complex number could be something like this. So 5 plus 3i is a complex number. This is the real part. So that's the real part. And this is the imaginary part. Okay, it's really easy to pick out the imaginary part because the imaginary part is always the one with the I. Now, do all complex numbers have to have both a real and an imaginary part? No. For example, this one doesn't have a real part. If you wanted to write, so here's another thing. A complex number is any number that's written in this form. Right? A plus bi. So in this case here, if you wanted to write this as a complex number, technically you would write this as 0 plus 7i. But we don't, because the real part is 0. So we don't normally write that. Okay? And you wouldn't, what if this was, what if you didn't have an imaginary part? Well, you would have just the real part. So what does this tell you? One thing it tells you is that the complex numbers, the set of all complex numbers is bigger than the set of real numbers, because a real number is actually considered a complex number. It's just that it's 0i. It's 5, or a plus 0i, if you will. Okay? Okay, so let me see. Is there anything else I want to say about that? Okay, so in the next video, what we'll do is I'm going to introduce the definition, and we'll go through this and do some more examples. Okay, have a great day.